Hello everyone, welcome to MONBUKAGAKUSHO Physics 2016 Part 2. And let's see the question. The right half of the XY plane is filled with a uniform magnetic field of magnitude B pointing out the page as shown in figure 2.1. And if you wonder what kind of figure it is, this one. Okay, so yep, this is just a particular type of graph which is very unique. Now, if you just have a glance on this graph, it's just a particle with speed v enters a field with the magnitude b. The magnitude of the magnetic field directed towards you, towards here, so it's towards you, and the particle undergoes a circular motion. Now let's get back to the question. Okay, so the first question is, the charge particle is positive or negative? Well, the answer is positive. So there's a charge of particle mass m entered the field region with speed v. The magnitude of the charge itself is q, and the trajectory is semicircle. Now, for the magnitude of force on the particle, well, this type of force is actually Lorentz force. So, the formula of Lorentz force for the moving particle with charge q, speed v, enters the magnetic field B, the formula is bqv sine theta. But as we have seen in the graph, which is this one, you can see that when v is here and b is directing towards you, they are forming 90 degrees. So we can change this theta to be 90, which is 1. So the answer is E, right? Okay, so find the radius of the circular orbit now. This way to find the radius, we can use the Lorentz force. And remember that it is moved circularly, right? So it undergoes circular motion. And we know that F is m times A, since A is the centripetal acceleration, because it undergoes circular motion. And the formula is v squared over r. We can cross the v. So r is mv over qb. So the answer is D. Number 4, find the time it takes the particle to travel from O to P. Now, the time for that it needed, we can actually use the same concept. F equals qvb, ma equals qvb, mv squared over r equals qvb. And remember that v is omega r, right? And v is also omega r. And remember that when the particle moves from O to P, so I actually has drawn a simplified version, a smaller version, that when particle move from O to P, it is R and R, right? So that is 2R. So we can change that. Let's do this, and you can change this into 2R. So we can cross this. So m omega equals qb, 2qb. And the formula for omega is 2p over t. T is the time that is needed. Cross this, and t equals pm over QB. So the answer is B. Now for number 5, now we change the magnitude of magnetic field from B to 2B, and we change the value of the particle speed from V to 3V. What multiple of the radius of the original circular orbit is the new radius now after these changes? Okay, so we are tampering around with the radius, and we know the formula is mv over qb. Since b is changed into 2b and v is changed into 3v, so we change that. It's equal to 3 over 2 mv qb. Then mv over qb is r. So the multiple of the new changes compared to the original is 3 over 2. So the answer is, yep, A. So that is everyone for number 2. I hope you understand of my explanation. This whole question is all about the basics of magnetic field. So the way that I do it, it is actually to understand the relation between each of the question. Because each of the question here is relying on the understanding of the magnetic field itself. They ask about Lorentz force, then they ask the radius, which we can change it into circular motion. Yep, it is for part 2, and stay tuned everyone for part 3.